a new idea. People will get excited about this. But in fact, what I got back was replies that, well, we already know how color vision works. We don't need a new theory. All we need is more data confirming what we know about the current model. And I kind of fought that as long as I could for a while through the peer review process. In the end, I finally had to sort of give up on that, and I kind of let it lay fallow for quite a few years until I tried again in terms and said, it's been so long, let's just put it together and get it out there, and that's why I put this book together, and so that it's at least out there, and people, I think, can judge for themselves.
This is actually one of the most exciting things when people become free with their discoveries and they actually no longer depend on the peer review process, which tends to guard the gate of what is considered accepted knowledge and accepted reality. So when you come in, or anybody comes in, with something that is not providing consistency in terms of the interpretation of what is or that could alter reality, peer review often functions to block discovery.
It's the thing is, peer review process is really good at what it's designed to do, which is, it certainly is designed to keep out real quack ideas or really nutty stuff, and that's fine. But on the other hand, it can be so stringent that, since the guardians of the gate, if you will, in the peer review process is also the ones very often who have an investment in the current view of things, that there's a lot of resistance in the end to really truly novel ideas. And so it's a process of this kind of push-pull that's going on that often works well, but sometimes can wind up, it's like throwing out the baby with the bathwater.
Let's talk about some of the ramifications of your new cone theory and model. Let's stand in the future that it's accepted. If this new model is received and integrated, it's out there working, let's say in a parallel universe. What benefits or what contributions do you see its existence making? Because obviously it opens the field for a whole new universe of discovery. But share what you're seeing, what your sense is of what the benefits are.
Okay, fair enough. I sort of see that as two basic things. One is maybe that, from the point of view of my background as a physicist, I see it as really kind of neat to be able to really understand something, to think like finally understand how something works. I like to know how things work, and in that respect, it's nice to know how, in fact, this marvelous system in the eye actually works. And just knowing that itself is from my point of view, a substantial reward. On the other hand, thing you mentioned, of course, about colorblindness, it's not obvious until we get into some details about it, but the model doesn't address some aspects of colorblindness, and in fact hints towards some ways that we can perhaps treat colorblindness, and that in itself could be pretty rewarding because something close to 10% of males of the human population have some form of color deficit vision, and because it's X-linked recessive genetics, only less than a fraction of 1% of females have that problem. But still, a large number of people have that issue, and there is some possibility that understanding how the retinal cones actually work and what happens in them and how they go awry could offer some way of trying to treat them. I got to stress, I'm not a clinician. I don't do work with human subjects and such. But as I talk about in the book, there have been some cases where people might have accidentally made some treatments that, in fact, improved people's color vision. And the field kind of ignored those treatments just because they couldn't understand how they could possibly have worked. But in terms of the model that I've been talking about, there's actually a very clear-cut mechanism of how they could work. And if I might mention that.
Sure.
Sure. The key part, I mentioned about how the the cones have to be kind of just the right size and shape to spread the spectrum along their length. Now, what I think can happen is that it's possible, that the cones have to be tuned to be exactly the right size to spread the spectrum. If they're too big, the spectrum won't be spread along their whole length, only down in the lower portion of them. If they're too small, all the light won't get in, and it won't be spread along the length. So, in fact, I think what happens, there's in fact two types of this main types of colorblindness, what's called red-green colorblindness. There are actually two types, one called protanopia, another called deuteranopia, if you like. And I think, in fact, again, I don't want to get into a lot of detail right now, but I think one type, the protanopia type, corresponds to the cones being effectively too small, and the deuteranopia type of red-green colorblindness corresponds to the cones being too large. And when I say too large or too small, because it's an optical waveguide effect that's involved here, it doesn't have to be the physical size of the cone, but actually it's controlled by the medium, the liquid that's around the cones, and in terms of what's called their refractive index. And by actually changing the composition of the liquid around the cones, the medium in the retina, you could tweak the size, the apparent size of the cone. And the one set of experiments that I referred to earlier, where somebody claimed that he cured colorblindness by giving some injections, I think what happened in that case was that, in fact, they had changed the medium around the cones, the refractive index of that medium, that brought it back into tune, if you like, and that changed somebody who had been colorblind into somebody who could, in fact, see normally. I think a lot of work needs to be done in that area, and that's a place that ought to be looked at. And I think, in fact, hopefully offers some real help for a lot of folks.
Do you think that this new theory of color could impact diseases like cataracts or glaucoma or other types of eye diseases? Because once you have a new paradigm, all of a sudden solutions come easier because you're actually looking at the whole thing differently.
Well, yeah, that tends to be kind of true throughout sort of the history of science. Once you understand something, it turns out that there are a lot of applications in a lot of other places. In the case of this, understanding how this color vision works, I personally don't think it would apply very much to a kind of disease as you mentioned, in terms of glaucoma or whatever. But there are a number of different kinds of color blindnesses that understanding how this thing works in the receptors might, in fact, apply to. And I would hesitate to preclude what it could or could not affect. But certainly that sort of thing is definitely a possibility. We've got to keep our eye out for it, if you will. Pardon the pun, if you will. Yes.
Is it true that in the military that soldiers are tested for color blindness?
Well, I think they probably are, but that's in a lot, in fact, a number of industries as well. For example, a lot of electricians, it's important they have good color vision because they have to they use color coding on resistor bands and so forth, so they have to know what they're putting together. And color blindness in a number of fields have been important. I suspect, certainly for pilots, it's also an issue, and has been an issue for a lot of fields. And if you ask most people who have color deficit vision whether they like to be able to cure it, yeah, I think most of them would say they would, for sure.
I have a general question to ask you as a physicist in the many areas that you've trained as a physicist. This is kind of off the charts of anything about vision, but I was wondering if you'd be open if I could ask you a question I've always been interested in. With someone at your level of understanding, do you see the human body as an electrical phenomenon?
Well, okay. Certainly our entire nervous system is based on the propagation of electrical currents, and all the messages and functioning in our brain occurs with electrical transmission of various types. I'd hesitate to say what could or could not be possible in that regard.